Hello guys, in this video I am going to teach you about Boolean operators and Bitwise operators. First let's talk about Boolean operators. When we are working with Boolean operators, we use two values and three Boolean operators. The two values are true and false. Those three Boolean operators are not operator, and operator, and or operator. In this file you can see the behavior of those three Boolean operators. First, let's take not Boolean operator. It has one input and one output. When we give input as true, it gives output as false. When we give input as false, it gives output as true. Now let's move to the AND Boolean operator. This AND Boolean operator has two inputs and one output. When those two inputs were false, it gives us false. And if input 1 was false and input 2 was true, it gives us false. And the input 1 was true and the input 2 was false, it gives us false. And input 1 and input 2 were true, it gives us true. If you decide to use these Boolean operators, you need to put these things in your mind, right? Now let's move to the OR Boolean operator. OR Boolean operator also has two inputs and one output, but the output value are different than this AND output. When our two input were false, it gives us false. And if our input 1 was false and input 2 was true, it gives us also true. And input 1 was true, input 1 was true, and input 2 was false, it gives us true. And our both inputs were true, it gives us true. Try to keep these values in your mind, and let's get into the Python program. First, let's see how to use that not Boolean operator in Python. I'm going to create a variable to hold our answer. Now let's use not Boolean operator. Type not. This is a keyword, that's why PyCharm shows us that word with orange color. Now let's put our value. You saw there is a one input to the not Boolean operator. Let's give true as input. Now let's print the answer. Now you can see it gives us false. We give true as input and we get output as false. When we put this as false, we get true. Yes, we get true. Now let's move to the AND Boolean operator. And you can see here AND Boolean operator takes two inputs. To use those two inputs with AND Boolean operator, first we need to put our first input. And to use AND Boolean operator, we use AND keyword. And I put second input to true. Now you can see the output is true because these both inputs are true. You can see here we get true when we use true as both inputs. Let's try other values. I put false instead of this true value. We get false. It's correct. This, when we put false as to input, we get false. Now let's change these values a little bit. I put one in first input to true, then we get false. Yes, we get false. Now this is same for all Boolean operator, and just you have to do put or keyword instead of this and run the application. We get true because we have first input to true and second input to false. Yes, we get true because we have first input as true and the second input as false. It gives us true. You can use two or more values with this or and Boolean operator. You can't use two or more values with not Boolean operator. You can use only one value with this not Boolean operator. Now let's talk about bitwise operators. In bitwise operators, we consider true as 1 and false as 0. I have typed 3 bitwise operators here, not bitwise operator and or and bitwise operator. These are the signs that we use to represent those 3 bitwise operators. This is for not, this is for or, this is for and. The behavior of these bitwise operators are same as the Boolean operators. This behavior, this not bitwise operators behavior is equals to a not Boolean operators behavior, and this or bitwise operators behavior is equals to Boolean operator, and this and bitwise operators behavior is equals to Boolean and operators behavior, right? And then we have another 3 different bitwise operators that we didn't met in Boolean operators. This is XOR bitwise operator. You can see down here I have typed the XOR bitwise operators behavior. It has 2 inputs and 1 output, as same as Boolean AND or Boolean OR. When we give false here, that when we give false for both 2 inputs, it returns true. And if we give false to input 1 and true for input 2, it returns false. And this is also false because this is same as the previous values. Now lastly, we supply true for both inputs and we get true. Then you can see this, then you can understand this behavior. When we give same input for to those inputs, that means this XOR or AND or gates can have multiple inputs than 2. It cannot contain only one input. We give only one input only for not gate, right? This XOR and AND gate and OR gate requires 2 or more inputs. When in this case we have 2 inputs. When our 2 inputs values were equal, then we get true. If you had 3 input here, then we get true only if our three inputs were same. That means if we give false for three inputs, we get true, and when we give true for those three inputs, we get true, because those all values are same. This is how the XOR bitwise operator works, but there is no XOR Boolean operator. We use XOR for bitwise operators only. And this is the sign for right shift bitwise operator. Now I need to shift bits. That means this shifts present bits by the value that we supply after this sign. In here I pass 1, that means I need to shift present bit once to the right side. And this is the sign for right shift bitwise operator. Now I need to shift bits. That means this shifts present bits by the value that we supply after this sign. In here I pass 1, that means I need to shift present bit once to the right side. This present bit, that means this true bit, is middle of the binary number. In this line I tell to move this present bit to right side of the binary number once, then this is equals to this, because this takes this present bit, it moves to the right side of the binary number once. And for one example, let's take 100 binary number. I need to shift this true bit 2 times to the right. This sign tells the Python interpreter to shift the present or true bit twice to the right side, right? Then this takes that true bit and moves to the right side twice. Then this is equals to this. And if we use that value again, we shift one time to the right, and this is equals to 0 1 0. Now we have left shift, and this is the sign that we use to represent left shift bitwise operator. That is same as this, but direction of shifting bit is different. This right shift bit moves the present, that means moves the true bit to the right side, and this left shift moves the true bit to the left side. And for example, let's take this number, and we need to left shift this by 1. Then this takes this true bit and it moves that true bit once to the left side, then that is equals to 100. And you can see this practically using Python language. Now let's get into the Python language to do some practicals on this bitwise operators. Now open your Python file. Sorry, this table need to change like this. Mistake, right? I did a mistake. Sorry for that. This table need to change like this. If we pass the same input for that 2 or more inputs, that accepts or XOR, we get false, right? If we even pass true for those all inputs, we get false. First, let's see how to use AND bitwise operator in Python. Now I'm going to store true and false value in two variables. Value 1 contains true and value 2 contains false. Now I'm going to create another variable to store our output. This AND bitwise operator is same as AND Boolean operator. All we need to do, first we need to pass the value 1 that we pass to AND. In this bitwise operators, we use a specific sign for AND. That sign is this. Now we use this sign. You saw we used AND keyword as Boolean operator. Now we are working with bitwise operator. To use the AND in bitwise operators, we need to put this sign and pass the second value. Now this contains our answer. Now it copy to output variable. Let's print the output variable's value. When we run this, we can see false. We know already if we pass true and false to AND, we get false. What about when we put this to true? You know now we get true. Yes, it's correct. Now to use OR bitwise operator with these two values, all we need to do, put OR Boolean operator sign instead of this AND Boolean operator. One thing I need to tell you, I have used these two pipelines to indicate OR bitwise operator, but that is wrong. I got that later, and we need to put one pipeline to indicate OR bitwise operator. Now instead of this AND, let's put OR bitwise operator. Now let's check the output. Now you can see we get true because we have supplied true for those both variables. Now let's put this one variable to false. Now let's see what we get. We get true. Everyone know the OR gate behavior that I explained you in Boolean operators. When we pass true and false to OR, we get true. Now let's use the NOT bitwise operator. I use value 1 for NOT bitwise operator. In Boolean operator, I have told you we can use one variable for NOT Boolean operator. This is same as this bitwise operator. We can use only one value with bitwise NOT operator. Now I'm going to use value 1. This is how we pass value 1 or any value to not Boolean operator. Now we need to work with not bitwise operator. To use bitwise operator, we need to put this sign, and now this value 1 contains false. That means this is equals to 0, right? This false equals to 0 and this true equals to 1. Now what does this do? It takes value 1 value, that means false we have, it pass that value through the NOT bitwise operator. Then let's see how our output will be -1, because this converts all the zeros to 1, not bitwise operator. It also always returns the minus, right? The minus value it returns for us. Now let's take some example for XOR Boolean operator. This usage is same as OR bitwise operator and bitwise operator. All we need to do, put value 1 and use the XOR sign and use value 2. Now let's run this application. Here we get true, because when we pass true and false, these are different values, and if you use two inputs, when that two inputs values were different, then we get true. But this two inputs value was equal, then we get false. Yeah, you can see we get false. In this file I have typed the XOR gate behavior. When we have two false, that means when we have same inputs we get false, and if we have different inputs, that means if we have different input values we get true. If we have same values for input, we get false. Now let's talk about shifting bitwise operators. I'm going to clear this lines. No, I don't need that. I use this value as binary numbers. This is for value 1 and this is for value 2. Ignore this 0b. This is a prefix that we tell the interpreter we are going to pass binary numbers, right? Now the interpreter looks at this as binary number. Now we have two binary numbers. Let me put these integer values. This binary number is equals to 1 and this binary number equals to 6. Now let's do right shifting. To right shifting I use the second value. I have explained what this shifting does before we get into the practice. Now I explain it in here. Binary numbers always contains 0 and 1. Then when we use shifting, it look at the ones, right? It look at the ones and move those 1 values to left or right. When we use left shift, it moves those 1 values to the left, and if we use right shift, it moves those 1 values to the right. Now second variable, that variable is value 2, contains 1 1 and 0. Now let's do right shifting. I need to move this 2 1 bits to the right side once. To do that I need to use value 2, that variable I'm going to shift once. This takes value of the value 2 variable as binary number. It shifts all the bits, all the true bits once. Then this is equals to this number 0 1 1. Then this binary number represents 3 as integer, right? Now let's see the output. Yeah, we get 3. Now let's see how to use left shift bitwise operator with this value. This is the sign for left shift bitwise operator. To shift bit left, I use value 1. Then I change here as value 1. Then it takes the true bit and move that true bit left once. Now this is equal to this binary number 0 1 0. Now this binary number is equals to 2. Now let's check the output. Yeah, we get 2. We get 2. Okay, we have completed bitwise operators. Now we have came to the end of the video. In end of the video, now we have came to end of the video. In the end of the video, I'm going to teach you another operator that we call as in-place operator. In-place operator can use with all the bitwise operators except not bitwise operator, and you can use that in-place operator with mathematical operators like addition, division, subtraction, multiplication, like that. Now let's see how to use that. I'm going to create a variable called number and I assign some value to that. That value is 0. Now this in-place operator, we can use increment numbers or decrease numbers or divide numbers and for etc. Now if we use some mathematical operators on this number, we need to make another value for store that expression value. That means if we calculate something, we need to store that value in another variable. Now let's see how to increase this number by 1 and assign that value into this number. This expression simply we can represent like this: number equals to number plus 1. This line is going to add 1 to number and assign that value to number variable. Now how many variables we have used in this program? Only one variable, only this number variable, right? This takes number variable and adds 1 to that and store that value back to the number. Then it contains 1. When we print the number, you can see the output as this. We get 1 because we increase the number by 1. Now we have a short way to do this. That is, now this expression equals to this expression, number plus equals to 1. Now this line is going to add 1 to number and save that value to the number variable. Now let's clear this line. Now you can see we get 1. The same answer as before expression. Now you can use this in place operator to decrease numbers and multiply numbers. To do that, instead of this plus operator, addition operator, we need to put subtraction operator to subtract numbers. Now I change this number value to true. Now what this does, it takes number variable and discrete one from number variable and store that back to the number variable. Now this is equals to this expression, number equals to number minus 1, right? This is long way to do this. This is a short way to do this. When we use in place operator, we can make expression more short, right? Now let's see the output. Now we get 1. When we use 3 here, we get 2, because we decrease 1 from number variable and we store that value back to the number variable. Now you can use this to multiply and divide and shifting bit. This is right shifting bit and this is left shifting, and for or and for and bitwise operators, right? Now we have came to the end of the video. Use this in place operator with those bitwise operators and mathematical operators and check the output, and share this video to others. If you learned something from this video, give a like to the video and subscribe my channel, and don't forget to click on the bell icon and set the notification for all. And if you have any question about this tutorial, please put that in comment section below, and I'll see you in next video.